Let's look at graphing some more complicated functions. So we're going to graph r equals 6 cosine of theta. So what I've done here is I've just made a t-table, and in that t-table I have come up with a bunch of different thetas. You'll notice that all the thetas I listed are just the angles in radians from the unit circle. 0, pi 6, pi fourths, pi thirds, pi halves, and so on and so forth. And we'll end up using lots of these today over and over. Now, what we're going to do is take each of these angles, make sure your calculator is in radian mode, and then all we're going to do is plug this radian, this angle, into the equation for theta, and then type that into our calculator. So if I type that in, I get 6. Then I move down and do the next one, pi 6. And if I type that into my calculator, it might give you a root, so make sure you push the button to change it into a decimal. Since we're graphing today, we want everything to be in decimals. And their decimal should be about 5.2. And so on and so forth. Just keep plugging them in, typing them into your calculator, and getting a decimal answer. Now before I keep writing these down, let's talk about graphing them. I want to graph these as an r comma theta point. So this would be 6 comma 0. So I'm going to go to a radius of 6 and an angle of 0 radians. 2, 3. So that looks to be about right there. And that's how we graph the point. This next point would be graphed as 5.2 comma pi 6. So I'm going to go to an angle of pi 6 and a radius of 5.2. So pi 6 would be right here, and I'm going to go 5.2 out. About there. And we keep doing that same pattern. So this next one would be 4.24 comma pi fourths. So I'm going to go to pi fourths and go 4.2 radius out. And I'm just getting all of these different points. And in the end, I'm going to connect the dots. Graph, just connect all these dots, and that's the graph of this equation. Now, let's talk about how do I know when to stop. How do I know when my t-table is actually done? You know you're done as soon as you have 2 points that are in a row that are the same as what you had before. So you'll notice that when you do pi and 7 pi 6, type those into your calculator, this is the point that's going to end up at pi, and this is the point that's going to end up at 7 pi 6. So those 2 points landed on top of points that I already had. As soon as you have 2 points in a row that do that, then your t-table is done. You have to keep your t-table going, though, until you get 2 points in a row that land on top of points you already have. So, understanding all of this, what I'm going to have you do is pause the video at this point, plug all the rest of these points into your calculator, get decimal answers, graph the points, and then come back to check your graph and see how you did. Let's see how you did. Hopefully your graph should look something like this, what I've got right here. If it doesn't, a couple things you probably want to check. First, check your list of points right here. Make sure they're all the same as the ones I've got. If there are any different, I would check your calculator work. You might have typed it into your calculator wrong. If all your points are the same, but your graph looks different, I would check how you graph them. A couple things to remember. Negative radius means to go in the opposite direction. If you're really struggling with this, it might help to start off by labeling what these lines mean. So this is 0 radians, this is pi 6, pi fourths, pi thirds, pi halves, 2 pi thirds, 3 pi fourths, 5 pi 6 pi, and so on and so forth. You can continue doing that. It might be helpful to label those so that when we do 2 pi thirds, we know it's this line, but because it's a negative radius, we go in the opposite direction. So I go to -3 right there. Hopefully that should fix any issues you had with graphing. And notice that my last 2 points at pi but -6 takes me there, and 7 pi 6 but -5.2 takes me there. So I had 2 points in a row that landed on top of points I already have that were the same. That's what tells me my graph, my t-table is done. So now that I have that, I can play connect the dots. To get that. And that is your first more complicated one. Let's make it even harder. Let's do B. This one, you will have to go around a lot more radians until you get 2 points that are the same. So I've already listed them right here, but you know in your table, you just keep going until you get 2 points that lay on top of 2 points you already have. Then you're done. Here's our new equation, 4 minus 2 sine of theta. So you're going to take all these radians, plug them into your calculator into this equation. Make sure you're in radian mode and make sure you get decimal answers. Then you're going to take all the points that you get from these t-tables and graph those points here to see what the graph looks like. So let's just for now work on plugging all these points into our calculator and writing out what the points are. So pause the video, type all these into your calculator, get the point answers, and then come back and check your points before you start graphing. Let's check your table. So here's the table I've got, table of values. Check to make sure that all those points are the same. If not, retype it into your calculator to make sure you get the same points I do. Now that you have all the points correct, now you can graph them. Remember, we graph them as r, theta. So this would be a radius of 4, angle of 0. Radius of 3, angle of pi 6. Now practice graphing all of those points and then come back to check your graph. Let's check your graph. So when I plotted all my points, this is the shape that I get. Kind of a cool looking graph. And you'll notice my 2 orange points at the end that were the same. As soon as you have 2 points in a row that land on top of points you already have, that's when you know that you're done listing radians. So that is it for this video. We have talked about creating a t-table, plugging those radians into our calculator to get points, and then graphing those points and connecting the dots to get a graph. In the next video, we'll do 3 more examples of these fun looking graphs with t-tables and calculators, and then you'll be done with 6.2.